Assalamualaikum warahmatullahi wabarakatuh. Hello guys, my name is Asfia. I'm studying at Islamic State University of Antasari, Banjarmasin. My major is Mathematics Education. Okay guys, I will explain you about addition, subtraction, multiplication, and division of fraction, and order of operation.
The first, addition and subtraction of fraction.
You can add or subtract fraction easily if the bottom number or the denominator is the same. To add two fractions with the same denominator, you simply add the numerators and keep the denominator the same. For example, to add 1/2 and 1/2, we just add the numerator and 1 plus 1 equals 2. But we don't add the denominator. We just use the same denominator in the answer, which is 2. So, 2 over 2 is a whole fraction. And that makes sense because if you add 1/2 and 1/2, you get a whole. Let's see a few more examples, like this one, 5 over 16 plus 2 over 16. Again, since the denominator are the same, it is easy to add this fraction. All we do is add the numerator together. 5 plus 2 equals 7, and that's the numerator of our answer. Then, we just keep 16 as the denominator of our answer. So, 5 over 16 plus 2 over 16 equals 7 over 16. Pretty easy, huh? But, what about subtracting fraction? Does that work the same way? Yup. If the denominator is the same, all you have to do is subtract the numerator and keep the same denominator if your answer. Here's an example of subtracting fraction with the same denominator. 5 over 9 minus 2 over 9. First, subtract the numerator. 5 minus 2 equals 3. Then, we just write the same denominator in our answer, 9. So, 5 over 9 minus 2 over 9 is 3 over 9. Yep, adding and subtracting fraction with the same denominator is easy. What do you do if you have fraction with different denominator?
If the denominator are not same, you may apply the technique mentioned above to make them the same before doing the addition or subtraction. To achieve this, we can use the following steps. First, find the LCM, least common multiple of the denominator of fraction. Then, express each of the fraction to an equivalent fraction with the LCM as the denominator. Plus, add or subtract it.
First, we will take the two different denominator and start making multiples of each of them. We start with 1 times the number, and then 2 times, and then 3 times, and 4 times, and so on.
It is helps to arrange these multiples in a small table, almost like a scoreboard, so that you can keep things organized and easy to find. We will stop making multiples as soon as we find an answer that's the same for both numbers. That answer is called the least common multiple, and it will become our new common denominator.
Once we know what the least common denominator is, we have to figure out which whole fraction. We will need to multiply our unlike fraction by to get equivalent fraction with the common denominator.
The solution is to use the same numbers that result in the common multiple. For example, if you multiply by 4 to get the common multiple for the first unlike fraction, then you will use 4 over 4 as your whole fraction. And if you multiply by 3 to get the common multiple for the second unlike fraction, then you will use 3 over 3 as your whole fraction for it.
It should make a lot more sense after you have seen a few examples. Let's start with the problem. 3 over 8 plus 5 over 24.
Step 1 is to take our two bottom number and make multiples of them to see if we can find a common multiple. First, let's multiply them both by 1. That's easy. We have 8 and 24. Next, we multiply them both by 2. That gives us 16 and 48. I still don't see anything in common. So let's multiply them both by 3. 3 times 8 is 24 and 3 times 24 is 72.
But look, we have something in common now. We have a 24 in each column. We have found the least common multiple of the number 8 and 24, and it happened to be 24. That makes sense if you remember your multiplication tables that 3 times 8 equals 24. So, now we know we are gonna use 24 as our common denominator. But, what whole fraction do we need to get it?
The answer lies in our multiples chart. To get our common multiple, we had to multiply our 8 by 3. So, we're gonna use the whole fraction, 3 over 3, for our first fraction. And our common multiple for the 24 was just itself. We multiplied by 1. So, we could use the whole fraction 1 over 1, but we really don't need to since multiplying by 1 won't change anything. We already have a denominator of 24 on the set, so we don't need to change it.
Okay, now we multiply. On top, 3 times 3 gives us 9. And on the bottom, 8 times 3 gives us 24, just like we wanted. Now, we have fraction with the same denominator and we can use our simple procedure to add them. We add the numerator. 9 plus 5 equals 14. And we keep the same denominator, 24. So, that's how you use the least common denominator method. And it's really not that hard once you get the hang of it.
The second, multiplication of fraction.
Multiplying fraction is super easy. In fact, it is easier than adding fraction. To multiply two fractions, multiply the two numerators and multiply the two denominators. The denominators need to be the same. When possible, we simplify. For example, 1 over 4 times 2 over 3.
Now, it looks like two multiplication problems that are being divided, and it looks just like a fraction. In fact, if we go ahead and do the multiplication, 1 times 2 equals 2 and 4 times 3 equals 12. Then we do have a fraction and it is the answer to our problem.
So, what does this all mean? Well, it means that to multiply fraction, all you have to do is multiply the numerators and then multiply the denominators. And ta-da! There's your answer. As always, let's see an example or two. Let's try this problem. 2 over 3 times 4 over 5. Now, we could rewrite the problem like we just saw. But that's not necessary as long as we remember the procedure.
First, we know our answer is going to be a fraction. So, let's go ahead and write a new fraction line for it. Next, we multiply the numerator. 2 times 4 equals 8. So, 8 is the numerator of our answer. Last, we multiply the denominators. 3 times 5 equals 15. So, 15 is the denominator of our answer.
There we have it. 2 over 3 times 4 over 5 equals 8 over 15. See how easy that was? And fun too. Even funner than video games. Alright, let's see one last example. Here it is. 1/2 times 4 over 3 times 3 over 5. Wait a minute. This has three fractions multiplied together. And that middle one looks like an improper fraction because its top number is bigger than its bottom number. Does our procedure work for this problem too? Yup. All we have to do is multiply all the numerator together and then multiply all the denominator together and we will have our answer. And this will work no matter how many fractions we have to multiply.
So, on the top we have 1 times 4 is 4, and 4 times 3 is 12. And on the bottom, 2 times 3 is 6, and 6 times 5 is 30. That means our answer is 12 over 30.
So, there you have it. Multiplying fraction is easy because fractions are just another way of writing division problems. But remember, there's another way to think about fraction. We can also use fraction to represent part of thing like half of a pizza, for instance. But does it make sense to multiply half of pizza by another half? Actually, it does. If you are thinking of fraction as part of something, then multiplying fraction is really like taking part of another part. For example, here's half of a pizza. You can see that if I take 1/2 of that half, then I get 1/4 of a pizza.
If we do the multiplication 1/2 times 1/2, you see that we do get 1/4.
So, that's why you can think of multiplying fraction as taking part of another part. In fact, sometimes, especially in word of story problems, you will see multiplying fraction written using the word of instead of times. They must ask, what's 3/4 of 2/3? And now, you will know they just mean what's 3/4 times 2/3. So, whether you think of fraction as part of something or as division problem, the procedure for doing the multiplication is actually the same.
The third, division of fraction.
In order to understand how dividing fraction works, we first need to learn about something called reciprocals. A reciprocal is just a fancy term for what you get when you switch the top and bottom number of a fraction. For example, if you have the fraction 1/2 and then switch the top and bottom numbers, you will end up with 2/1. 2/1 is the reciprocal of 1/2, and 1/2 is the reciprocal of 2/1. And an interesting thing about reciprocal is multiplying a fraction by its own reciprocal will always give you 1. That's because you will have the same multiplication problem on the top and bottom. So, you will end up with a whole fraction which is always 1. Okay, that's nice. But what does reciprocal have to do with dividing fraction? Well, reciprocal let us do a really cool trick that makes dividing fraction easy. Whenever you have to divide something by a fraction, you can just multiply it by the reciprocal of the fraction instead, and you will get the correct answer. And that's good news because multiplying fraction is so simple. This trick of multiplying by the reciprocal works because fractions are really just mini division problems. So, when you multiply something by 1/2, it's the same as dividing by 2, since 2 is below the fraction division line. And dividing by 2 is the same as dividing by 2/1 because you can turn any number into a fraction by just writing 1 as the bottom number, right? But look, reciprocals. That's why multiplying by 1/2 is the same as dividing by 2/1. And it is true the other way around too. So really, it's kind of like you never have to divide fraction. You can just rewrite your division problems so that you're multiplying by the reciprocal instead. Then when you multiply, you will get the answer for the original division problem. As always, let's see a couple examples of how this works so you will really understand. Let's try this problem. 3/4 divided by 2/7. Okay, so the first thing we want to do is rewrite our problem. Instead of dividing by 2/7, we can multiply by the reciprocal instead.
The reciprocal of 2/7 is 7/2, So our problem becomes 3 over 4 times 7 over 2.
Oh, I should mention a mistake that a lot of students make when they first learn to divide fraction. Sometimes students take the reciprocal of the first fraction, the one that's being divided, or even the reciprocal of both fractions. But you only want to take the reciprocal of the second fraction, the one you are dividing by.
Okay, now that our problem has been changed to multiplication, it is easy. Just multiply the tops. 3 times 7 equals 21, and multiply the bottom. 4 times 2 equals 8, and we have the answer to our fraction division problem.
So, 3 over 4 divided by 2 over 7 is 21 over 8. So, that's pretty easy. But let's try one more example. Let's try 15 over 16 divided by 9 over 22. Again, the first thing we want to do is rewrite our problem. We will change the divided by 9 over 22 into times 22 over 9. Now, all we have to do is multiply. But since these numbers are kind of big, I'm going to use my calculator to help. Let's see here. So we have, alright, on the top we have 15 times 22 equals 330. And on the bottom, we have 16 times 9 equals 144. So, the answer to our division problem is 330 over 144. Alright, that's how you divide a fraction. You just multiply by the reciprocal and you have your answer. If you can multiply fraction, then you can divide the fraction too.
The last, order of operation.
Order of operation is just a set of math rules that tell you which math operation, like addition or multiplication, to do first. Why do I need rules to tell me which operation to do first? Can't I just do them in any order I want? Well, that's a really good question. And to answer it, we're going to give two totally different people the same math problem to solve. The problem is 2 plus 5 times 4.
I like addition better than multiplication, so I'm gonna do that first. Let's see, 2 plus 5 gives us 7, and then I just multiply that 7 by the 4, and I get 28. That was easy, but you'd better not copy my answer.
Ha 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 ha, don't worry, I'm not gonna copy your answer, because I want the right answer. And I prefer multiplying, so I'm going to do that first. Let's see, 4 times 5 equals 20, and then I will add the 2, which gives me 22 for a final answer.
What makes you think that's the right answer? All my calculations were correct. I even checked it with a calculator.
The only calculator I need is right up here, and then correct answer is 22.
Okay, so which one of these guys do you think is right? Neither one made any mistake with the calculation. They just did the operation in a different order and get different answer. Well, since there were no mistake, in a way, they were both right. But math would be a very confusing subject if there were different answers to the same problem. And that's where order of operation can help us out. The order of operation rules are a way for us all agree on the order that you should do math operation in. And if we always do operation in the same order, then we will always get the same answer. So, now that you know why we need order of operation rules, let's find out what those rules are. There are basically 4 of them, and they go something like this.
First, do operation in parentheses and brackets. Next, do exponents. Then, do multiplication and division. Last, do addition and subtraction.
Let's take a closer look at each one of these rules and see some examples where they will help us. First, on the list was do operation in parentheses and brackets. Now, in case you haven't seen parentheses or brackets used in math before, let me briefly explain how they work. Parentheses and brackets are used to group things together, and our rules tell us to do any operation inside this group first. For example, have a look at this problem. 10 times 4 plus 5. It has 3 numbers and 2 operations, multiplication and addition. But 2 of the number and the addition symbol are inside parentheses. That means that they form a group and we need to do that part of the problem first.
4 plus 5 equals 9. So, the part inside the parentheses can just be replaced with the simplified value 9. Oh, and once you do the math that's inside parentheses and get a single number like this, you usually don't need to show the parentheses anymore. Now that the parentheses are gone, we just have one operation left to do. We multiply 10 times 9 and that gives us 90 as our final answer.
So, parentheses can really help you know what part of a problem you're supposed to do first. But what if you get a problem that has more than one set of parentheses like this? 5 minus 3 plus 6 times 2.
Fortunately, it doesn't matter which set of parentheses you do first. You just need to do everything that's inside the parentheses before you do anything that's not inside parentheses. In other words, we need to simplify both of our parentheses groups before we can do this addition in between them. The first group, 5 minus 3 simplifies to 2, and the second group, 6 times 2 simplifies to 12. Now, we can do the last operation and add the value that we got from simplifying to plus 12 equals 14.
Okay, now that we know we always do operation in parentheses or brackets first, let's take a closer look at the second rule that says the next thing we do is exponent. Now, if you haven't seen exponent before, they are just a way of writing repeated multiplication.
For example, the repeated multiplication 4 times 4 can be written as a shorter form as 5 multiplied twice, and 4 times 4 times 4 can be written as 4 multiplied 3 times, and 4 times 4 times 4 times 4 can be written as 4 multiplied 4 times. Get that idea? The small number is called as exponent or power. It just tells you how many times to multiply the bigger number together.
So, after we take care of any parentheses, simplifying any exponents becomes the next highest priority. For example, in this problem, we have to simplify the exponent before we can do the other multiplication.
The exponent is telling us to multiply 5 together twice. So, 5 times 5 is 25. And after we do that, then we multiply the result by 3. So, 25 times 3 is 75.
Alright, now we are gonna look at the last two rules together. These two rules are really important because they deal with the most common math operation: addition, subtraction, multiplication, and division. And the rules tell us that we need to do multiplication and division before we do addition and subtraction. To see how these rules work, let's look at a few quick examples that use those basic operations. First, let's try this one. 2 plus 5 times 4. Aha! Does this look familiar? Yup, it is the one we gave to my two friends earlier. And now that we have our rules, we see that we have to do the multiplication before the addition. 5 times 4 equals 20. And then we add the 2, which gives us 22. So the second guy was right. Now let's try this one. 3 times 5 minus 1.
Our rules tell that multiplication is higher on the list than subtraction. So we do 3 times 5 first. That gives us 15. And then we subtract the 1, which leaves 14 as our final answer. Here's one with division and subtraction. 20 minus 10 divided by 5. And since division has a higher priority, we do the 10 divided by 5 first, which equals 2. And then we subtract 2 from 20 and get 18 as our final answer.
And here's one last problem. 40 divided by 4 times 5. Which do we do first? The multiplication or the division? Our rules don't tell us. Well, that's because multiplication and division are tied for priority or importance. So are addition and subtraction. And that's the reason we need an extra part at the end of each of these rules that says from left to right. If you have a problem that has both multiplication and division, then you're supposed to work it from left to right. That's because in some cases, you can get a different answer if you go from right to left.
For example, in this problem, if you work from right to left the wrong way, you would do the 4 times 5 first and get 20. And then 40 divided by 20 equals 2. But if you go from left to right, you would do 40 divided by 4 first, which is 10. And then 10 times 5 equals 50.
Wow! The direction we went made a big difference. So, whenever you have a problem that has a mixture of multiplication and division, or a mixture of addition and subtraction, you know to do the operation in order from left to right. The order of operation rules, it also apply to fraction. Hi guys, that's my explanation about addition, subtraction, multiplication, and division of fraction, and order of operation. Might be useful, and sorry for the lag in this video, and thank you. See you next time.